Let's now move to measures of variability. It may also be useful to consider not only where the center of the data is, but also how spread out the data are. There are several ways we can measure the variability of the data. There's the range, the interquartile range, and the variance, and its related concept, the standard deviation, and finally the coefficient of variation. In this course, we will be focusing mainly on the concepts of the variance and standard deviation. The range of a data set is simply the difference between the largest and smallest data values. What you just do is take the smallest value, take the largest value, and subtract the first from the second. As you can see, it's very simple to calculate. The problem is that it's very sensitive to the smallest and largest data values, i.e., if you have extreme values, then your calculation of the range could be distorted. So again, in the apartment rents example, arrange the data, the 70 observations in ascending order. The smallest value is 425, the largest value is 615, and hence the range is 190. The variance uses all the data, not just the largest and the smallest values. Intuitively, what we do is for each data point, we see how far it is from the mean, x bar for the case of the sample, or mu for the population. But what we care about is only its absolute distance. Some numbers, of course, will be higher than the mean, and some will be lower than the mean. Hence, if we subtract the mean from the actual data point, the difference will be positive in the case of some, negative in the case of the others. But we don't really care about the sign, we only care about the magnitude. Hence, what we do is we square those differences, then take their average, and it's computed as follows. In the case of a sample variance, in the numerator, as you can see, for each observation, xi, in this case I equals 1 to 70, subtract the sample mean from each observation, square it, do this 70 times, add them all up, divide by n minus 1, which is the sample size minus 1, and that is the sample variance. In the case of the population variance, take the population mean mu, subtract it from each observation, and whatever the difference is square, add them all up, and divide by the population size, big N. That is the population variance. The standard deviation is then simply the square root of the variance. As you can see, the sample standard deviation is just the square root of the sample variance. The population standard deviation is just the square root of the population variance. There's another notion called the coefficient of variation, which indicates how large the standard deviation is in relation to the mean. Hence, once you've calculated the standard deviation, whether sample or population, and it's in the numerators here, divide them by their respective means, sample mean or population mean, and then times 100, and the value in percent is the coefficient of variation. So, let's summarize numerically. If you were to actually do the calculation for all the 70 data points of the apartment rents, this is the variance you would get, 2,996.16. Getting the standard deviation of that, you would get, getting the square root of that, you would get the standard deviation of 54.74. Finally, if you divide 54.74, which is the standard deviation, sample standard deviation, by the sample mean of 490.8, you would get a value of 11.15%. which, as you can see from the box, means that the standard deviation is about 11% of the mean. Remember how we worked with group data, where we created a table with several classes, and for each class we calculated its frequency? We can use group data also to calculate means. What we do is that we use the frequencies as weights, and then we calculate what are called the weighted means or the weighted variances. But for that, you have to assume that for each class the midpoint will be the value. That is, you're assuming that all the observations within that class will have a value equal to the midpoint. And what you then do is this formula. Use this formula, using the means, using the frequencies as the weights. So for instance here, this is how they grouped the apartment data. They divided it into 10 classes, and they observed the frequency of each. So as you can see, there were 8 apartments with rents between $420 and $439, 17 with rents $440 to $459, and so on. So what you do, let's look at the first row. What is the midpoint of 420 and 439? It's 429.5. What is the midpoint of the second row? It's 449.5. So each midpoint you multiply by its frequency. So 429.5 times 8 equals 3436, and so on. Add up all these in the third column, which is the 34525, and divide by 70, which is the number of observations. The weighted mean that you will get is 493.21. As you will see, it differs somewhat from the actual sample mean of 490.8. That's because we've been using the midpoints of each class rather than the actual values. The variance similarly can be computed by using weights, and these are the formula. So as you will see in the first row, look at the midpoint, 429.8. Subtract the sample mean from it, you'll get minus 63.7. Square it, you'll get 4058.96. Multiply it by 8, and you'll get the last column. Add up everything in the column, and you will get 208234.29. Let's continue. That sum you then divide by 70 minus 1. Remember, for samples, the numerator we use is n minus 1, the sample size minus 1. As you will see, the sample variance is 3017.89, and the sample standard deviation is the square root of that, which is 54.94, which differs by only about 0.2 from the actual standard deviation we had computed earlier.